Hello everyone, welcome back to our channel. Let's discuss the next named reaction, that is Fischer Indole synthesis. The name itself indicates indole synthesis. This reaction is very much useful for the preparation of the indole derivatives. Let's see the statement. Cyclization of aryl hydrogens in presence of acid catalyst to produce indole derivatives. What are the reactants here? Aryl hydrogens. Aryl hydrogens are subjected to the rearrangement in presence of the acid to get the indole derivatives. Already we know that how can we prepare the hydrogens. Carbonyl compounds treated with the hydrogens to produce hydrogens. See this? Initially we have taken phenyl hydrazine, PH, NH and H2 treated with one carbonyl compound, that is RC double bond O CH2R. RC double bond O CH2R. These two are involving in the reaction to produce phenyl hydrogen. This is the moiety which is the reactant in this particular reaction, subjected to acid catalyzed rearrangement to produce indole derivative. Let's see the mechanism. Initially we have taken this particular phenyl hydrogen. The phenyl hydrogen in presence of the acid catalyst, what is happening? The transfer of hydrogen takes place from the carbon to nitrogen. See this. In this way. Transfer of hydrogen from this carbon to nitrogen. Thereby we are getting this kind of moiety. This one is involving in the 3,3 sigma tropic rearrangement. In order to identify the 3,3 sigma tropic rearrangement, we need to identify the bond between two nitrogens as 1 and 1 dash. These two atoms held together by this single bond, right? So 1 and 1 dash. Thereby 1 dash, 2 dash, 3 dash, 1, 2, 3. The 3,3 will be connected. Single bond formation. That is 3,3 sigma tropic rearrangement produces this kind of moiety. Here the phenyl ring is losing its aromatic character or not? So in order to regain its aromatic character, what we are doing? We are forming a pi bond by the elimination of the hydrogen. Thereby we are coming up with minus charge or not here? The minus charge is attacking this carbon, thereby these pi bonding electrons moving towards nitrogen means nitrogen is taking negative charge or not? The H plus is moving towards this nitrogen. That's why NH minus means NH2. We are giving one more H plus now. NH2 and H plus produces NH3 plus. Okay, NH2 plus H plus NH3 plus. The elimination of NH3 and H plus generates indole substance. So in this way we can produce the indole derivatives. See this? Phenyl hydrogen, 6-membered cyclic ring. So initially hydrogen produces hydrogen or not? Simply this H2 and this O removed in the form of H2O produces this kind of product. Thereby we will come up with this kind of moiety. Okay. Next, PHC double bond O CH3. Say similar kind of product will be formed. But if you see this one CH3 C double bond O CH2R. So here acidic proton available, here acidic proton available. That's why we will come up with two products. Okay. If you see this one, by doing the Fischer Indole synthesis, we are coming up with this kind of moiety or not? 6-membered, in between 5-membered. Two 6-membered rings fused by 5-membered ring or not? If this membered ring is also having the alternative double bonds, then the moiety is called as carbazole moiety. 5-membered ring fused with 2 6-membered ring. This is the carbazole moiety. In order to synthesize the carbazole moiety, we are having a reaction called as Bucherer-carbazole synthesis. Bucherer-carbazole synthesis is the extension of the Fischer Indole synthesis. What we are doing, see this? Take the phenyl hydrazine and this kind of 6-membered ketone. We will come up with hydrazone or not? See this. Phenyl hydrazine, 6-membered ring, we will come up with this kind of moiety. Simply what we need to do? We need to form pi bonds here or not? In order to form the pi bond, we need to remove 2 hydrogens from these 2 carbons and 2 hydrogens from these 2 carbons. The removal of hydrogen is commonly called as oxidation or not. That's why what we are doing, oxidation phenomena. Similarly, from beta-naphthol also we can produce carbazole derivative. Initially, the beta-naphthol involving in the ketoenol tautomerism. The ketoenol tautomerism produces this kind of 6-membered ketone or not. Now that is treated with phenyl hydrazine followed by your indole synthesis. Finally, we will come up with the carbazole derivative. So in this way, we can synthesize indole and carbazole derivatives by using the Fischer Indole synthesis. Okay, thank you.